I want to bring on Dr. James Newenschwander, who I know is in the middle of his practice. We're going a little bit long, so thank you for taking the time. Tell me about these studies that we're talking about when it comes to T cells. You were on just 2 weeks ago. We talked about how T cells naturally have this ability to just fight, the enemy outside of what we sort of described as the walled city. But then if they penetrate that wall, that's where the antibodies have to start fighting inside the cell. But there's more discovery about the T cell. It's not just this natural fighting ability that happens naturally, but there's a memory in T cells that's now being discussed. Tell me about this information.
Well, yeah, this is an article in Cell that hasn't been published yet, but they were talking about looking at people who had recovered from COVID-19 and had talked about the responsiveness of their T cells, both their helper T cells and their cytotoxic T cells to the COVID. Now, what they found was they had a set of controls, and these controls were frozen samples that they had from 2015 to 2018. So regardless of how early you think COVID showed up, these samples were pre-COVID. And when they tested the T cells in those samples, what they found was about 50% of the time, the T helper cells in those samples responded to COVID. So because these people hadn't been exposed to COVID previously, clearly there was either some type of cross-reactivity, or perhaps there was too much similarity between the non-spike proteins of COVID and the previous infections they had. They also went back and tested these people to see, had they been exposed to the beta coronaviruses, and that's what COVID is, a family of these viruses. So they had previously been exposed to that family. So that allowed them probably to make these memory T helper cells that were able to just spontaneously react. Now, with the cytotoxic T cells, it wasn't quite as good. It was about 20% of the non-exposed patients that had cytotoxic T cells that responded. And again, part of that may be just the way they did the assay, but still it's pretty good. When you talk dark matter, if we're talking 50%, that might be your 50% right there.
So 50%, let me just get this right. It appears that by having potentially a cold last year or the year before, which is a coronavirus, that there's a broad enough immunity that was established by our T cells that they're recognizing COVID-19 and fighting it like how we sort of think of a vaccine, or how, having had the measles infection as a kid, how we used to have lifelong immunity. We are seeing a large population, maybe up to 50%, that simply from having a cold, then, as we just heard from Dr. Friston, they actually can't then contract COVID-19. Is that right? Because their body fights it?
Well, we have to always look at the data in terms of what we're looking at. Obviously, these were not people that were exposed to a virus. This was something going on in a petri dish. So we have to look at the data that tells us the T cells responded. Does that mean that they're not going to get an infection? We don't know, but common sense would say, hey, if you already have an immune response to this virus, in all likelihood, you're not going to get an infection from it. Somebody interestingly said, well, maybe if the immune system's already revved up and they get exposed, that might actually be a bad thing, but usually it's not. Usually that's going to mean you have protection against that infection, and in this case, we're talking about the COVID. So again, these patients, and it doesn't necessarily just have to be from a previous coronavirus vaccine, or excuse me, not a vaccine, but an infection. It could be from any virus. If there is enough cross-reactivity in the T cell receptor with the target on the coronavirus, then it's going to react. And that's what they're talking about. That, we don't really know, does that give you immunity? But we do know that those are the cells that protect you in the long run with other infections. So it would make a lot of sense that that's your 50% that he's talking about.
It's interesting because, earlier in the show, we were talking about how Paul Oppett's really afraid of rushing a vaccine. And he and both Peter Hotez are saying things like, okay, some of these trials are showing antibody production from the vaccine, but that may not mean anything at all. And in these studies, it seems to me that there is more focus now saying the T cell part of your immunity, which is different from antibodies, may be far more important than antibodies. So describe for those of us that don't understand the difference, a T cell versus an antibody, What are we talking about, and why is it that antibodies may not actually matter when it comes to COVID-19, or at least not as much as T cells?
Right. So if you're dealing with any intracellular infection, you need some sort of cellular immunity to respond to that. And this is the animation here. You have the virus, that's the pathogen, being enveloped by a macrophage, and it's being expressed on the surface of that macrophage using these proteins called MHC class II proteins. Those proteins are going to bind with the T helper receptor, and that's going to get that macrophage to release this interleukin 1, gets the T cell to release interleukin 2. And that's where the magic happens, because that's going to stimulate these cytotoxic T cells, and we'll get back to those, and then also stimulate the B cells. So the cytotoxic T cells are different. So this is a normal mucosal cell. It's going to express the stuff on the surface of the cell using a different protein, but that's a protein that the cytotoxic T cell recognizes. When it can bind that protein, now what it's going to do is actually release compounds to tell the cell it's time to die. When the cell dies, the virus dies with it. Also, it's going to, the interleukin 2 is going to get these B cells to start getting activated. They get stimulated by a helper T cell. They divide. They start making antibodies. These antibodies will then float around looking for the viral target, bind to it, and then again tell these macrophages to chew it up and destroy it. So the B cells, some of them can become memory B cells. So these don't make antibodies, but they will protect you in the future. And you don't just have memory B cells, you have memory T cells. I mean, this is all very simplistic. The signaling is a lot more complicated than what's in this animation. But again, if you've got these memory T cells, you're going to have immunity for a long time. One thing you learn about immunity is no matter how much you know, you start reading, you start researching, you realize, I really didn't know that much, because this stuff is constantly evolving. Our ability to understand what's going on. You know, when I trained, I knew there were T cells. Then I learned there were T helper and cytotoxic T cells. And now there's like Th1 helper cells and Th2 helper cells. Now there's like 6 or 7 helper cells. So they all have different functions and they respond to different cells. But in this case, we're talking about these are Th1 helper cells and these are cytotoxic T cells. That's what they're finding in these papers. That seems to be what's giving people the immunity, and that's what allows you to destroy the virus in the cell. If you're talking about antibodies, the antibodies are just going to deal with what's circulating in the blood. You know, they're not going to deal with an actual infected cell. The antibody can't get into the cell. And that's why the T cell immunity is critical to actually clear the infection out of the body.
All right, so then brilliant, and the animation was very helpful. And though it may seem simplified to many of us, I think we're still saying I need to watch that animation like 4 more times. Which, by the way, if you want to watch anything on this show or get any of these documents or these scientific studies, just type in ICAN, ICAN, right now if you're on Facebook, and we'll send you that information. Or if you're on YouTube or somewhere else, just text us at 33222 and type in ICAN. Or if you donate, if you're a recurring donor, at the end of every week, you get a very detailed newsletter of every single link presented in the show, and that's best the way to do it. Go to icandecide.org. Lastly, and I know that here comes the big dangerous question. Is there a way that I can feed or help my T cells? I mean, as far as health, what part of my diet, or are there vitamins that I'm not going to ask you to say cure anything, but do we know about vitamins supporting our T cell growth so that we have this robust reaction, which seems to be so important when it comes to COVID-19?
Yeah, we actually have some evidence. I mean, you know, we don't have multi-center, large, placebo-controlled prospective studies, but we have evidence. We know that that T cell receptor, when it binds that antigen, and whether it's a helper T cell or suppressor T cell, it needs vitamin D to do its thing. Vitamin D helps the DNA get expressed and transcribe genes that T cell receptor needs to do its thing. So that's what's going to get these T cells going. And we know that the vitamin D helps. There was actually a study in, I believe, in Singapore earlier this year, where they gave vitamin D, they gave B12, and they gave magnesium. I mean, these are simple nutrients. And yet they were able to reduce the incidence of ending up in an ICU by like 80%. I mean, this is
Wow.
pretty incredible that just simple nutrition can make that big a difference. And we also know zinc plays a huge, huge role in how the immune system responds, whether it's targeting, we talked a little bit last time about the cell's response to the virus, not an immune cell, but like a mucosal cell. It needs zinc to do that. You need zinc to make these cytokines. You need zinc to control the level of these inflammatory cytokines. If you don't want to go into cytokine storm, you need adequate zinc. So these are simple little nutrients. Anybody can take them. You don't need a prescription for me to do that. You want to take care of your body. And I think it's really important you give people some tools here, rather than just let's all cower in the basement and hope for the best. Let's do something. Let's get the vitamin D. Let's get these nutrients into our body. Our immune system is beautifully designed. It's designed to take care of this stuff. We need to take care of it. And we're not emphasizing that enough. One thing I just want to say about Paul Offit and Hotez, I don't necessarily agree with their views on vaccines, obviously, but these are smart guys. They know what vaccines do. That's why they're ringing these warning bells. Most of us are very much afraid of what is this going to do to the immune system over the long run, particularly when it comes to autoimmunity, because those T cells are going to be that Th1 response. It's good to get rid of viruses, but it's that same response that can cause autoimmune disorders.
Really great information, Dr. New. Thank you for taking time out of your practice to join us. I will look forward to the next time we have you on. Thank you so much. If you liked that clip, then be sure to check out our live broadcast of The High Wire every Thursday morning at 11 a.m. Pacific Time. You can watch it on Facebook, YouTube, iTunes, and Twitter. We'll see you there.